Okay. All right. Now, so what I was talking about is this. For example, let's say we had these two fractions. We have 5 1/6 minus 2 2/3. Okay. What I saw on a lot of your papers were two different things. First thing was when you find the common denominator here, the common denominator between 6 and 3, here and here, would be 6. Okay? And so you convert the fraction to 6 on the bottom. Okay, and what a lot of you I saw you did is okay, what did we do to 6 to make it 6? Multiplied by 1. So we do the same thing the top. So that one stays the same, so that's okay. Where you missed it was here, what did we do to 3 to make it 6? Multiplied by 2 and make that a 4. Okay, and that's the step that you missed. You just put, instead of putting 5 1/6 minus 2 4/6, you put 5 1/6 minus 2 2/6. Well, 2 2/6 is not the same thing as 2 2/3. Okay? Remember, when you're making equivalent fractions, you've got to multiply the top and bottom by the same number for it to stay equivalent. Okay? So that's one thing that I saw that y'all were doing on the papers as we were grading today. You weren't doing that step. The other thing that I saw was this. A lot of you would have, like, for example, 2 and 22 over 24, and that would be your answer. Okay, well, we talked about the other day that if these two numbers, if the numerator and denominator of the fraction have a common factor, then you must reduce it. That can't be the answer. Okay, it would have to be 2 and 22 over 24, and I would divide it by 2 over 2. Okay, because that's the common factor, and that would be 11, and that would be 12. It would be 2 and 11/12. Okay, and so that was the two common mistakes that I saw on your papers as we were grading today from the section of adding fractions. Okay, the subtracting fractions are very similar. Okay, you still have to have common denominators. We still have to reduce if possible, all those things. There's a little less reducing when you subtract, all right, because you don't have adding together and making a mixed number and all that. So there's a little less reducing when you're subtracting than when you're adding, but there still is occasionally some reducing, simplifying the fraction that you must do. Okay, so let's just go ahead and look at this first problem, 5 1/6 minus 2 4/6. Okay, I've taken and done a harder problem to begin with, so hopefully we can get it out of the way and understand it. We have 5 1/6. Can I do this? 5 minus 2 and then 1 minus 4 over 6. Can you do 1 minus 4? No, we can't, okay? So we can't get to that step yet because we can't take 1 minus 4. So what we have to do then is we have to do this. We have to borrow from the 5, making it 4. Okay? We borrowed one whole number from 5. Okay? And so what I have is I want to add that. I want to add that to the 1 over 6. Okay? Here's the 1 that I just borrowed. But can I take 6 plus 1? Can I do 6 plus 1 on the bottom? I can? Have to be the same. Okay? They have to be the same denominator. So what number would represent 1 but it has 6 on bottom? What would the fraction be to equal 1 with 6 on the bottom? No, hang on. Listen, 1 over 6, that's equal to 1? No. 2 over 6, is that equal to 1? No. 3 over 6? No. 4 over 6? 6 over 6, you get the idea. So, this has to be 6 over 6. Now I can add it to 1/6. So this gives me 4 and 7 over 6 minus 2 4/6. Okay, that's where I borrowed, was right here is where I borrowed, and that equals 1. Okay, I borrowed from the 4, making it 5. Okay, it would be just like this. Let's say we have pizza. Okay, everybody likes pizza, right, Brandon? Everybody likes pizza. What kind of pizza you like? Any kind? You like anchovies? Dead fish on it? Well, you just said you liked any kind. You don't like dead fish? No, I don't either. How about goldfish? Put some goldfish on it, like real goldfish, not like the cracker goldfish, but the real goldfish. See, I like Canadian bacon and pineapple. I like that one. That's a good one. The Hawaiian pizza. I discovered that, I always forget, is it Pie 5 down there? Oh, yeah. I discovered that place. That's a good place to eat. I enjoy that. All right, back to this anyway, back to math. And I'm getting to math. If we have pizza, okay, let's say we have 5 pieces of pizza left, okay, and Brandon wants to be a pig and have 6. So we'd have to borrow from another pizza, right? Okay, we would borrow 8 slices. Okay, so we don't say we add 1 slice to the 5 that are there. We're adding 8 slices to the 5 that's there. That makes a total of 13 slices. Well, if he takes 6 of them, oink oink, okay, then how many are left? 7 pieces. Okay, so that's what we're doing here. Okay, we have 1 slice of pizza left, and somebody wants 4 slices. Okay, and so we're having to take and borrow from one of our whole boxes of pizza, okay, and add it to the slices that we have. So we can take the 4 away. Okay, so now we have 7 slices of pizza. Okay, and I'm going to take 4 away. How many would that leave us with? 3 slices. So that would be, whoops, wrong color, 3/6. And then I'm going to take 2 whole pizzas from it as well, from the 4 pizzas that I have left. So taking 2 away from the 4 whole pizzas, we have 2 full pizzas left over. Okay? So we have 2 3/6 is our answer, right? No. Why? Okay, we can reduce the 3/6. So the 3/6 we reduce by 3/3. Okay, and that is 2.5. And that is our answer. Okay, so we still had to reduce. Okay, even though it's a subtraction problem, a lot of the reason why we had to reduce is because we were borrowing in the problem. Okay? Now, not all of them are going to be that difficult. A lot of them you're not going to have to borrow on. The way we know if we have to borrow is if the second fraction is larger than the first fraction once you have the common denominators. Okay? You'd never borrow until you have common denominators. Okay, that's the very first step in any time we're adding or subtracting fractions is we must have a common denominator. Okay, must have. That's the first step. Okay, let's look at another one. Let me get my book up here. 5/6 minus 1/3. All right, 9 5/6 minus 1/3. Okay, a lot of times people get confused on this type of problem because one of the fractions is a mixed number, the other fraction isn't. Okay, it's sort of like when you have 1.5 and you're subtracting 0.4 from it. Okay, a lot of times you get messed up, you don't line up the decimals, and so a lot of times there's some confusion here, but there shouldn't be. Okay, first step is still the first step. We must have common denominators. Do we have common denominators? No. Okay, we have a 6 and a 3. Those are not the same. We must make them the same. Fortunately for us, I happen to pick one that uses the same denominator as the one we just got done with. Okay, so what is the common denominator between 6 and 3? 6, what it was for the last problem. So this one stays. Okay, so what did we do to 3 to make it 6? Multiplied by 2. So I must do the same thing to the top, which makes that 2 over 6. Okay, what did we do to 6 to make it 6? Times 1. That makes that 5. Now, remember that we do not do anything, once we come up with common denominators, we don't do anything to the denominator as far as adding or subtracting it. Obviously, if we subtracted the denominator every time, we would get 0. And you can't have 0 on the bottom of a fraction. It's not mathematically possible. Okay? But the denominator stays the same. Once we make it the same, it stays the same. And so now we're just going to take 5 minus 2. So we're going to have 5 minus 2 over 6 and 9 minus 0. Okay, I'm just saying there's a 0 right there. Okay, just to let us know that we're doing that. And so that gives us 9 and 3 over 6. Well, lo and behold, same problem we just basically had with no borrowing. That's 9.5. Okay, remember how we got 9.5 is we divided by 3 over 3 to the top and bottom of the fraction. Remember, this number here that you reduce by always has to be equal to 1. You can't reduce by 3 on top and 6 on bottom. Okay, because 3 over 6 is not 1. 3 over 3 is 1. Okay? Okay, let's look at another one. 5 and 5 over 12 minus 1 and 7 over 8. Probably going to be another borrowing one. Because 5 over 12 is not close to 1 and 7/8 is close to 1. Okay? So, what is the common denominator of 12 and 8? So, if I'm counting by 12s, 12, 24, 36, 48, and if I count by 8s, 8, 16, 24, 32, what's the first number I run into? 24. Okay? So 24 is going to be my common denominator. Remember, nothing happens to the whole numbers when you're finding the common denominator and making the equivalent fraction with the new denominator. Only things happen is to of course, the bottom and top number of your fraction. So, what did we do to 12 to make it 24? Multiplied it by 2. So we got to do the same thing at the top, which makes that 10. Okay? All right, now, what did we do to 8 to make it 24? Multiplied it by 3. So I do the same thing at the top, makes that 21. Okay? So now I have 5 and 10 over 24 minus 1 and 21 over 24. So somebody walks in and they want one whole pizza and 21 of the 24 slices of another pizza. Okay? Well, I've got 5 whole pizzas and 10 slices of the 24 left. So I have to borrow. Okay? I have to borrow from the 5, making it a 4. Okay? When I do that, all I've got to do basically when I borrow is add the denominator to the top number. So all I basically have to do is add the 24 to the 10. What is 24 plus 10? 34. And so that gives me 4 and 34 over 24 minus 1 and 21 over 24. Okay? Now, I can find and subtract. So I have 4 minus 1 on the whole numbers, and I have 34 minus 21 over 24. Okay, well, what is 4 minus 1? 3. What is 34 minus 21? 13 over 24. Now, I know that there's no common factors between 13 and 24 because 13 is prime, and it's not a factor of 24. Now, if that had been 13 over 26, then that would have been obviously something we could reduce. Okay? All right, I want you to try this one on your own. Looking at them here. 3 5/7 minus 1/2. Okay, try that problem on your own. I'll give you a couple of minutes to do that one. All right, who has an answer? Okay, Joy, what'd you get? Do what? 3 and 3/14, is that what you said? Yeah. All right, let's look at this one. All right, the common denominator between the two fractions is 14. Now, this one you could get away with just multiplying the two numbers together. 2 is prime, 7 is prime. So when both the numbers are prime, then you just multiply them together, because if they're prime, they won't be factors of the other number. And so basically then, we ask ourselves, what did we do to 7 to make it 14? Multiplied by 2 to the top and bottom. Very important step that you do that, okay? What do we do to 2 to make it 14? Multiplied by 7. That makes that 7 over 14. Okay? Now we just have 3 minus 0 and 10 minus 7 over 14. And that's where we get our 3 3/14. Once again, no reducing is needed. Okay? All right, let's look at one more for you to do on your own. Let's do this one. 8 4/9 minus 4 2/3. We're actually going to look at two more, this one and one more. So go ahead and do that one on your own. Then I'll have one more that I need to show you because it's a little bit different. If you're not done, keep working on it. Okay? I'm going to start doing it, but keep working on it if you're not finished. Common denominator here is 9. Okay? We multiplied the bottom we multiplied 3 by 3 to get 9. So that puts a 6 on top there, multiplied by 1 over 1 here, which makes that 4. Can you take 4 minus 6? No, we can't take 4 minus 6, so we have to borrow, make that a 7. And I just add 9 to 4. So that makes 7 and 13 over 9 minus 4 and 6 over 9. Okay, and so that gives me 7 minus 4 and 13 minus 6 over 9, which gives me 3 and 7 over 9. Anybody not understand where we got that, where we got all the information there? If you do, don't hesitate to ask, because I'll be glad to explain it. Okay, I want to look at a specific problem. Yes, Xavier? Right here? Because I borrowed. That's where I added here. I borrowed 1. I borrowed 1 from the 8, making it 7. And when I borrowed 1, I basically took 4 over 9 and added 9 over 9 to it. Right here. And that's where I got the 13 over 9. Okay? This one here, 5 and 7/8 minus 4. Okay, that was an easy one. Okay, move out of the way here. That one you just simply subtract 5 minus 4 and put your 7/8. So that would be 1 and 7/8. Where it's a little bit different is when you have this. 3 minus 1 and 5/7. Okay? 3 minus 1 and 5/7. Well, what you have here is you basically have 3 and 0 over 0 minus 1 and 5/7. Okay? Well, can I make a common denominator of 0? No. So I have to borrow. I borrow from the 3, making it a 2, and now I have 2 and 7 over 7, minus 1 and 5 over 7. Okay? Where I got the 7 over 7 is just when I borrowed. The reason I made it 7 over 7 is because of that denominator right there. If that would have been 5 over 9, then I would have made this 9 over 9. If that would have been 5 over 12, then I'd made this 12 over 12. Okay? So that's the reason I made it 7 over 7. So now you just subtract them. 2 minus 1 and 7 minus 5 over 7. 2 minus 1 is 1. 7 minus 5 over 7 is 2 over 7. And that's your answer. All right. Your homework due tomorrow. 5.4, 9 through 28. Now, folks, I just did 9 of the problems. We just did 9 of the problems. There's a total of 19 problems. So nobody should come in tomorrow with a 1 out of 19, 2 out of 19. The worst you should do is 9 out of 19. Okay? So that's almost half. All right? So if you do nothing else but, I don't have time, go home and copy the notes into your homework problems, okay? So 5.4, 9 through 28, due tomorrow. Make sure you use pencil. Today's date is the 27th. Today's date is the 27th.